Hello friends, today I'm going to solve LeetCode problem number 1834, single-threaded CPU. So in this problem, we are given an array task. It's a 2D integer array, and each of the tasks in the array is labeled from 0 to n minus 1, and the value is the in-queue time and the processing time, which means the time at which the task is available, and processing time is the total time the task takes to complete. So now what we need to return is the order in which we could process the task, and the task is processed by single threaded CPU, which means that only one task can be executed at a time. So let's see how we could solve this problem. And also, like, given constraints are that the CPU will choose the shortest processing time, the task with the shortest processing time first among all the available tasks. And if the processing time is the same, then it will choose the task with smallest index. Now let's see how we could solve this problem. So this is an example given to us, and we need to solve this task. So we have the in-queue time and the processing time. Now what we need to do is, since the in-queue time, we need to get the task which has the in-queue time, the least in-queue time. We know, like, the current time, starting time could be like 0 or anything, but now from 0 we need to move to the next time, right? So we take the least time as the starting time. So yeah, so what do? Is we take the least in queue time among all of these four tasks. The least in queue time is this one, right? So we take this as the current time, and this becomes our first task that we need to process. So we start from the first task, and then we know that it takes two times, right? So let me just create a time slot here. So what's given here, this task is available at time 1, and it takes two time slots, 1 2. So it takes two time slots. So starting from 1, it takes two time slots, and the next task would be available at 3. So there is like numerous times that we could just keep going, but let's start from time slot number 1, and this task takes two processing time of 2, right? So task number 1 will start from task number 1, and it will still be running task number 2 in this slot as well. Now in the next time slot, what do we have? Now we have 3. We could start any task which starts from 2, which has in queue time 2 or 3. So how many are there? Well, basically we have two tasks which has in queue time 2 and 3, right? And among these, what do we need to do is we need to process the task which has the least processing time, because since these two are available, we take the one with the least processing time, which is this one. So now we executed this task, and this task also takes two time slots, so one time slot, two time slot. Now we have reached time 4. Now how many tasks do we have available? We still have this one available, and we now also have this available as well, because the in queue time for this task is 4, and since we have already reached 4, now which one would we execute among these two? Which one has the least processing time? This one, right? So we'll execute this one, and it takes only one time slot, right? So we'll execute the task number 4 on this time slot, and then next we will execute this one, the last remaining one. So this would be time, since it takes 4, so the last one would be 2, and it will take the time 2 time slots. So basically what we need is we just need to return the order. So what's the order? The first one is 1, next is 3, next is 4, and the last one is 2. So this is the order that we need to return as a result. Now we know what we need to do. Now let's see how we could actually solve this sort. First of all, we need to sort. If we are already given this array in a sorted order of in queue time, but if in case it wasn't, then we need to sort. First of all, sort based on in queue time. So based on the in queue time, we'll sort our array initially. Our task array initially will be sorted based on the in queue time, and then what we will do is we will create a queue of all the available tasks at that point of time. So this queue will have all the available tasks at the current time. And what will we do is in this queue, since we have all the available tasks, we will sort this queue based on the processing time, because among all the available tasks, we need to process the task which has the least processing time, or if the processing time is same, then we process based on the index. So we will sort based on processing time, if not index. So we'll sort based on these two factors, and then while we sort, we will process the first element from these like queue. So that will result in the final result here. So now let's see how we could solve this problem in the code itself. So first of all, let's define the length rule, and now let's sort our task based on the in queue time. So what's the in queue time? In queue time is the first element of each of, so a comma b, a 0 minus b 0. Now once we have sorted this, what we will do here is also, okay, before sorting, what do we need is we also need to keep track of index, right? Because here what's the case is that if the processing time is same, then we need to process is based on the list index. It's given here, right? Based on the smallest index. So we actually need the index as well, and if we sort our task, then the index is gone, right? The original index is gone. So that is why what we'll do is we will map our task. We don't need this here, so okay, let me just so basically now this task has both the in queue time, the processing time, and the index as its value. Now we will sort it based on the in queue time, and then now let's create our queue, priority queue. So per queue equals to empty array. Also let's create our resulting array, and then let the current time be equals to 0 initially. Okay, not 0 initially, the current time would be the least the first item in the task array. The in queue time, that would be the in queue time. So the first item and the in queue time. Now let's perform our evaluation. While the length of the result is less than the length of our task, because the length of the result should be equal to this. So until and unless it's not, we will keep executing. Okay, and if Okay, we also need the in-queue index. In-queue index to keep track of which index we are executing. So it will be the first index in the task array. And now here, if now what we need to check is if the queue is empty. If priority queue is empty, that is the length is equals to 0, and if the current time is less than the time of our index that we are currently executing the process for. If the current time is less, then what do we need is we need to update our current time to the time of the task that we need to process, because this is the next task that we will be processing. So basically we need to reach the time, right? So if it is the case, then we reach the time, and then let us also set the current size of the priority queue length, because why do we need this is we need the current size to find the time if we need to sort the queue or not. So I'll tell you why do we need the current size right now. So now what do we do is while current time is less than or equals to the time, the in-queue time, task at in-queue index. Okay, this is not in-queue time, this is in-queue index, which means that if the task is available at this time, by this given time, then what do? We put it into the queue, into our priority queue, right? So we push our task to the priority queue. So now we have pushed our task, and what do is we also need to increment this value here, and once all of the tasks which are available at this given time is pushed into the queue, now what do is we check if we need to sort out array or not. So what do we check is if the current size is less than the length. If it's less than length, which means that we have made changes to the priority queue, and changes in a way that we have added other elements to the priority queue, new task to the priority queue, and if we push new task, we need to sort it, right? If we just pop, then we do not need to sort it because it's already been sorted. So we are only going to sort it if we have pushed new elements into it. So since we have pushed new elements, because the length is greater now, so we sort our array based on two conditions. So what are the two conditions? The one condition is shortest processing time, and the next condition is smallest index. So if the processing time is equal, which means what is the processing time? Processing time is the second element. So if 1 equals to b, then we sort it based on the index, else 1, we sort in based on the processing time. So once it's sorted, now what do we also need to do is we need to process the task, right? So the current task is equals to priority queue dot, so we process the first element from our priority queue, and then what do is we update our resulting array because we are processing the task, right? So the resulting error value would be the index of the task that we are processing. The index is at index number 2 of this current task. And then because since we are processing the task, it will take certain time, and the time is at index 1 processing time. The current time plus the time it takes to process is the current time in the next time we start processing the next task. And then finally return our result. Now let's see what's the matter. Okay, we need to return. Cool, let's submit it. Great.